Hey, 20-2s, here we are in our next lesson. What we're going to look at here is we're going to start adding and subtracting radicals. Here's the good news about this lesson. You've done something very much like this before. Let's go back and let's look at how we would add and subtract polynomials. So when we would add and subtract polynomials, what we would do is we would look for like terms. So we would say, okay, our x's are like terms. So we would subtract those. 3x minus 1x is 2x. And we'd go and look at our y's. And we'd say, oh, look at there's a y and there's a y. So there's a like terms. And we would add those and we get 9y. So how we added and subtracted polynomials is we looked for things that were similar. Guess what we're going to do here with radicals? The exact same ideas. So on the first one here, root 7 plus 3 root 7. I'm going to call these things. I'm saying, okay, I've got 1 of the first one and 3 of the second one. So I have 4 root 7s. That was easy. On the second one over here, though, notice now I've got root 20 plus 6 root 5. I can't add these together. They're not similar because the radicands are not the same. They're not similar. So guess what we're going to do? We're going to turn these into mixed radicals in simplest form. So remember root 20, I would say, okay, what's a perfect square that goes into 20? 4. 6 root 5, not going to do anything there. Square root of 4 is 2, so 2 root 5. And now these are similar. I can add them because the radicands are the same. So 2 plus 6 is 8. There we go. So for us to add and subtract radicals, what has to be the same? The radicand must be the same. That's it, friends. So this is why turning things into mixed was so important in the last lesson. Right? Okay, let's try another one. So root 242 minus 5 square root 11. All right. So what I'm going to do here again is this is where it's really important you've got those perfect squares listed somewhere. So I say to myself, okay, look at 121 is a perfect square. That's a factor of 242. And root 11, well, there's nothing I can do to the 11. So square root of 121 is 11 root 2 minus 5 root 11. Now, what some people will start to do is they'll go, oh, look at, I can subtract these things because I see 11s in 2 different spots. No, you cannot. You cannot. There's nothing we can do with this. The radicands are different. There's nothing we can do to change them to be the same. That would be our final answer. So on occasion, when you're adding and subtracting these things, you won't be able to add and subtract all terms. All right. Now, how do I check my work? How do I see if what I've done is correct? So what you're going to do again is you'll pull up your calculator. So I'm going to pull my calculator up here. If it'll let me. It's always a great debate whether it'll actually let me show my calculator to you. There it is. Okay, and so what I'm going to do is I'm going to punch in the question we just did, which was the square root of 242 and then minus 5 root 11. So I punch that in my calculator, hit enter, and that's what I get. Now what I punch in my calculator is what my final answer was. So my final answer was 11 root 2 minus 5 root 11. And comparing the two, they're the same. Therefore, I've done it correctly. So that's how you check your work on every single radical question. Okay? It's the easiest thing to do in the world to check your work. But some people just don't want to do it, right? So please, please, please check your work. Okay, what about with cubes? Okay, no big deal. Cubes are the same thing. So what I say to myself is 8 is a perfect cube. So 8 times 2. 54, 27 is a perfect cube. That's a factor of 54. Cube root of 8 is 2. Remember, you need that index of 3 right there. And on the second term, cube root of 27 is 3, so I go 4 times 3 is 12. And now we have the same radicand, the 2 and the 2, right? And so now we can add these together, just like that. There it is. So friends, that's how you add and subtract radicals. Nothing too difficult about it, but the thing you have to remember is that the radicands must be the same. That's the big deal. Alrighty, I'll see you next time.